A very good morning to Dr. Sohaila. So today we are going to present our data analytic programming project, and the title of our project is the customer personality analysis. So before we start our presentation, I would like to introduce you to some of my teammates first. We have Lee Si-yuan, Lo Yu-chong, and me, Alvin Hee-jun-shong. So going up next. So the purpose of doing this project is to implement what we have learned in the DAP class across the entire semester. And the goal of this project is to find out which cluster of the customers tends to have a stronger purchasing ability, and definitely the company can more focus to market the products to the only cluster of customers. So basically, the data that we have chosen is from Kager, and the name of the data set is Customer Personality Analysis, and is created by Dr. Omar Romeo Hernandez. And the purpose of Dr. Omar Romeo Hernandez is to perform a customer segmentation through this data set. So basically, we have find out a total of 6 research questions in this project. The first is how many hidden cluster of customers are there in this company. So basically, we will utilize unsupervised learning, which is clustering, to perform this question. So up next is what is the biggest group of customers visiting the shops that brought the higher sales? Depends on marital status, education, as well as income level. So up next, we have the question 3, which is what is the visitor volume of company website, and what is the type of customer mostly spend on, and what is the purchase type that customers prefer, and the last question is there any correlation between the amount of web visits per month and the number of web purchases?
Okay, thank you, Alvin. First of all, we check whether there's a missing value in our data set or not. So in order to do this, we use ISNA method and SUM method to calculate the total number of missing values in each column. So after we print the output out, so we found that there's a column named income which have missing values. So in order to deal with this, we replace the missing value with this mean. The method we use is FILNA. In the method, we input the incomes columns means, and we set the in place to true. Next, we check for duplicates. The method we use is called duplicated, and with the output, we found that there's no duplicated columns. After that, we check whether our data is in correct format or not. In order to do this, we use dtypes method, and with the data display, so we found that DT customer, which is supposed to be stored in date time format, is stored in object format, which is string. In order to deal with this, we use toDateTime method, and to convert it, we check whether our data is sensible or not. In order to do this, we use value count method to list out data that is available in the column. The columns that we check are those columns that used in our research. And after we use the method, we found out that education and marital status columns has a variety of data, and we also found out that it can be simplified. Let's say for the education column, for example, the PhD, master, and 2N cycle actually can be categorized as postgraduate. So in order to do this, we use replace method. And in the replace method, we enter a dictionary which have a mapping of data that we need. And finally, in order to check whether they already been replaced, so we use the value count method again.
Then I would like to talk about the data aggregation and group operation we perform in this project. First thing we did is that we try to combine several features into a simpler and easier to use new feature. For example, we combine the amount of wines customer purchase, the amount of fruits customer purchase, and the amount of meat products customer purchase, etc., 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 into a new feature called total expend. Total expend basically shows us the total amount of spent by each customer in the company. We also did that for other features also. For example, total children. It shows the number of children that each customer have. Total accepted campaign. It shows that the number of campaign offers that each customer accepted. Lastly, total purchase. It shows the number of purchases that each customer made. We also use some old features to generate some new feature. For example, we use the year birth column to calculate the age of the customer. Secondly, we also use DT customer, a column that shows the date that customer has enrolled into the company, to calculate the number of days customer has enrolled into the company. So the first thing we did is that we determine the biggest day of DT customer, and then we create a new column for that and call it max date. Using the max date column, we calculate the day engaged. The day engaged basically is the number of days that customer has enrolled into the company. So this is the result.
Next, we have the data analysis and data visualization part. So before I start, I would like to let you all know the benefits of data visualization is to allow the business user to gain insight into their vast amount of data. So we have plot a bar graph of total expenses against the marital status. So from the chart above, it can show that both relationship or single marital status have relatively similar total expenses, indicating that both of this group are having a strong purchasing ability. Moving up next, we have plot a bar graph of total expenses against the educational level of the customers. So it clearly can be seen that the postgraduate has outperformed the undergraduate in a large amount of number. This indicates that maybe most of the postgraduate, they have a stable job or income that could support them in buying products that they in favor to. Whereas most of the undergraduate, they are still studying and do not have any stable income yet, resulting in a weak purchasing ability. So moving up next, we have plot a histogram of the income level of our customers. So we have plotted a histogram of the income level of the customer in this data set. So we can see that the income ranging from 35K until 40K has the highest frequency, which is a total of 183. Furthermore, we can see that most of our customers' income in this data set we have selected, their income is much below than 100K. Only a few are above 100K. Furthermore, we have plotted a histogram of the number of web visits in the last month. So it's very obvious that the number of 7 times of website visiting has the most number of counts, which is 383, followed by the 6 and 8 times with a total count of 349. We can see that only 11 customers who does not visit the web since last month out of 11,909 total customers. This has indicated that online shopping might have become a trend or a new norm to most of the people. So they are willing to do online shopping rather than going to retail. And we believe that the more the website visit, the more there might be more chances the customer placing the order.
Besides those charts, we also plot a pie chart, and this pie chart is for the types of product that customers spend on. Next, from this pie chart, we can know that wine's products have the highest percentage, which is 50.17%, while meat have the second highest percentage, which is 27.56%. So from this chart, we also can find that customers prefer more on meat compared to fish, and this also answers the questions 4, which is we can say that customers mostly spend on wine's product. Okay. Besides that, we also plot a grouped bar chart for the total amount spent on each category of product based on marital status. From this bar chart, we can find that the patterns of total amount spent for both marital status are the same. If you want to get the descending order of the total amount spent, it will be wines products, then meat products, then gold products, then fish products, then sweet products, and finally fruits products, which have the lowest total amount spent. This answer the research question 4. Next. Besides the grouped bar chart, we also plot a bar chart, which is for the number purchased based on purchase type. Okay, next. From this bar chart, we can see that the in-store purchase has the highest amount of purchase, while for web purchase is the second highest. Okay, so from here, we can answer the research question 5, which is customer prefer more on in-store purchase. Next. Okay, next is correlation heat maps between number of web visit and number of web purchase. So from these heat maps, we can know that there's correlations of negative 0.056 between these two variables, and the value is near to 0. Yeah, and we can say that there is no linear relationship between these two variables. So this answer the research question 6, which there is no correlation between these two variables.
For this part, I will talk about the machine learning operation that we did in this project. The very first thing we did is that we removed all the unnecessary columns. These are the columns that we have removed. The reason we did that is because all these columns actually have a better representation, which is these newly generated features we created previously. And then we also remove these 3 columns. The reason we remove these 3 columns is that in the dataset documentation, there is no clear column definition for these 3 columns. And then we apply the label encoding to every categorical columns that we have in our dataset, which are education and marital status. We use the label encoder function from the scikit-learn library. The reason we did that is because we want to convert every string value into a numerical value that computer can understand. So here is the result of label encoding. Feel free to pause the video and take a look. Next, after converting every string value into numerical value, we should also apply the feature normalization to every numerical values, because this can make sure every numerical value will share the same scale. To achieve this, we will use a standard scaler. Standard scaler is a function that makes sure every numerical value will have a mean value of 0 and also a variance of 1. So what you see here is the result of standard scaling. So after the label encoding and also feature normalization, now we have the data ready already, and it's time for us to do the clustering. But for clustering, since we use the k-means clustering algorithm, it needs us to determine the number of clusters it needs to form. And to find out the optimum clustering point, we will use a loop, and every time in the loop, we will use a different number of clusters. And then for every cluster, we will record down the WCSS value. After we recorded down every WCSS point, we will use that to plot a graph of WCSS point against the number of clusters. So this is the graph that we plotted. And then by using this graph, we will apply a method called elbow method to determine the optimum cluster point. Elbow method is a method in which we look at the graph and then find the point which makes the line has an obvious turning. So this is the point that makes the line has an obvious turning, and it indicates that the optimum cluster point is 2. So we use the optimal number of clusters to create our final k-means model. And then after we create the final k-means model, we use that to make the prediction on our feature normalized data. And then we assign the prediction result to the original dataset. Finally, with the final models we created and also the prediction result, it's time for us to visualize our machine learning results. So first of all, we plotted a scatter plot of income versus total expense. And then we also apply the hue color using the clustering result. So we can see that the first cluster has high income and also high expense, while the second cluster has low income and also low expense in the company. We plotted another swarm plot, and then from this swarm plot, we can see that cluster 1 definitely has a bigger population than the cluster 2. Next, we plotted a bar chart of the number of accepted campaign between both clusters. And we can say that cluster 1 tend to accept campaign offer more often than cluster 2. We also plotted a series of graphs so that we can tell the difference between cluster 1 and 2 and use this difference to create customer profile for cluster 1 and 2. So we plotted a graph about age, educations, marital status, number of website visits, and number of children. So this is the customer profile we created for cluster 1 and also cluster 2. First of all, for age, cluster 1 and cluster 2 have the same age distribution. But for education, we notice that cluster 1 customers are mostly postgraduate and graduate, while cluster 2, some of them are still undergraduate. Moving on next, for marital status, cluster 1 and cluster 2 also have the same distribution pattern. However, for web visits per month, it is an interesting point that cluster 2 customers tend to have a higher web visit volumes compared to cluster 1 customer. But for total number of children, cluster 1 customers seems to only have one or no children at all. Finally, for the campaign offers, cluster 1 customer are the group of customers that always tend to accept it more than cluster 2 customer. In the conclusion, we managed to answer all the 5 research questions for this project and also come up with some useful insight. We also managed to implement the K-means clustering algorithm to do customer segmentation. From the customer segmentation, we came up with a profiling of 2 clusters of customers so that the company can make good use of it for their future improvement. That's all from us. Thank you.